Very good morning. Today we are going to discuss about virtual circuit networks and datagram networks. We'll wait for 5 minutes. All the participants has to join. Once they join, we will start our sessions. Is my voice clear, ma? Do you have any disturbance in this? Am I audible? Please let me know in chat box. Okay, good. Network layer is the very complex layer in all over 5 layers of TCP/IP model, as well as network layer. The main role of that network layer is forwarding and routing. These two are the basic uh, responsibilities of your network layer. In this, there may be a having connection oriented or connection less. Both are in comes under connection. For the connection oriented services also we will have 5 layers, and connection less also we will have the same 5 layers, and network layer is going to take the responsibility of forwarding and routing. While forwarding and routing, the same thing. Forwarding is nothing but you will have a link between uh, link or switch. You will have a switch. Every device will have in all over the world. Every network device will have uplink and downlink. Okay, input link and output link. Output links, input links. Okay, you can call input links and output links. Whereas your end device means your laptop or mobile phone. It will have only. No, I haven't shared anything. Just I am talking about the network layer. I haven't shared anything. Just I am speaking. In every the end device will have only downlink and uplink. That means either you will receive the data or you will post the data. Okay, the both the things in end device, that is your laptop or your desktop or your mobile phone, whatever the network end devices. But in case of routers, switches, there may be a n number of input device. That means whenever the switch is connected to 10 or 20 device, more number of device, that is we are not going to take care that particular thing. But how many number of devices, if it is full duplex links, if that links are that cables are net links are full duplex, in that case every link is as considered as one input and output. Both the links are the single link, one single link, consider it as in link and out link also. Whenever your that particular link is sending some information to the router, we will consider as in link. Whenever you are sending some information to that particular same link, in the that router is sending some information to that link, is considered as outlink. Okay, we are going to find there are forwarding and switching both the things here. In this case, host or end devices will not play a major role, but the devices which are mm, intermediate, that network devices, routers or switches, they will follow most of rules, and this total network criteria will depend on that particular thing. That why your end device will have only one thing, either send or receive the message. That thing. Okay, only one device. You do not have any other more than other links. But in case of switches and routers, there are so many links. Okay, I will share only 68 to have participated. Okay, today we are going to see network service models. Okay, I will show the chat box also. Okay, now till now we have seen that forwarding and all the things we have discussed, that forwarding and routing, the network devices will have the forwarding table or routing table would be there inside that particular thing. Every time while you are getting that particular packet or information to that particular router, it is going to check the field of your header field and value of that particular thing, and whenever it is finding that particular thing is related to it, it is going to check the routing table or the forwarding table information, and it is going to check the outlink information, and for that particular outlink it is going to forward the message or the route the message. With the help of routing tables and routing algorithms, we are going to work out these forwarding and routing information. Okay, routing or forwarding the information, how we are going to do with the help of routing. If you do manually, that will be very toughest job for you. If you do some mistake also, it will affect very lot to the network, and it is very costlier than the uh, automatic things. Okay, for this you have DHCP, dynamic host allocation protocol. Okay, the DHCP particular thing would be there. Even in our college we are going to use the same thing. While you are connecting to your Wi-Fi or your network, that means when you connect to FS1, FS2, any network, your mobile device or your cable, you need not to worry about thing. Your DHCP server will allocate you a logical IP address, 10 dot some 11 dot some IP addresses would be there. Subnet mask, it is going to allocate for that we are going to discuss in this chapter, network chapter, how it is going to allocate the IP addresses dynamically. Whenever you disconnect that particular thing, your IP addresses will be collapsed, and you are not going to get same IP address after that particular thing. Okay, every time you are connected to the Wi-Fi, your DHCP server or the routing algorithms or that particular server is going to network allocation table is going to take care of these IP addresses and all the information in your systems and your network. Today, we are going to check how network service models will work in your network layer. I have some questions and doubts regarding the network layer. First one is, can the transport layer rely on network layer to deliver the packets to the destination? Okay, transport layer is the upper layer than your network layer. It is going to send some segments to your network layer. What that network layer will do, it will take that segments and it will packetized into a datagrams, and after that it is going to transfer to the next layers, and at the receiver end also it is going to same thing. It is going to receive from the frames from the data link layer and forward to the transport layer as segments. Okay, how if I am saying my network layer is doing all this work, how come the transport layer is uh, perfect, or it is not, it is going to rely on that particular, depend on that particular network layer for delivering the packets to the destination, properly transmission of the data. First question. Second question, when multiple packets are sent, that means I have n number of packets. Why? But for the sake of retransmission, we will every time our network will cut down the whole information into the small packets, and that packets are multiple in number. Okay, will they reach in order? That means whenever you are sending any packets through your network layer, that packet should be, every packet should have its own numbering. That means sequence numbering format we have discussed in the data link layer also. Sequence numbering, will they reach in order? That means at the receiver and also they have to have the sequence numbering and all the thing. But we are not discussing about the data link layer. Network layer also, when I am sending from transport layer to data link layer, then in the middle where there is a network layer. Network layer has to compress that particular segments into datagrams, and datagrams also he is sending to the frames. Next layer, that is data link layer. Is that particular packets are in order? That means sequentially they are going to reach at the particular end or not? That we that have I have a one doubt. Next doubt. Third one is, will the amount of time between two sequential packets is same? That is nothing but your jitter, how we discuss. That means whenever I am sending two packets one after another, if they reach at the destination in proper way, then only it will work properly. Otherwise, what will happen when the jitter, the best example, your YouTube videos, your video will come fast, that pixels will come fast, after that audio is coming slow. In that case, what will happen? Your video thing, that imaginary thing, image thing is move forward, and your voice will backward. In that case, there may be a chance of disturbance. You are not going to depend on that particular that particular network because of your jitter. Your network layer is responsible for this particular jitter or the things. So I have doubt, is network layer is capable of the amount of time between the two sequential packets at the sender end is equal to that particular receiver end or not? That is also one of my doubt. Okay, next, congestion in network. First, we will discuss about congestion. What is congestion? Whenever I am using any cable or any network or any links, I am sending lots of data, GBs, MBs, terabytes of data from one network to another network I am transferring. Okay, there may be a chance of your cable is capable of 20 Mbps transferring the capacity. That means 20 Mbps it is can transfer from your host, your access point to your ACT fiber. Okay, ACT fiber or Airtel fiber or Geo fiber, whatever you take. Okay, your cable is capable of 20 Mbps per second, but your family members are more, you are continuously watching, or you are continuously watching videos, or you are sending text messages up and down. In that case, there may be a chance of busyness in your cable. That means whenever you are accessing, more number of people are accessing the videos, YouTube videos or some other videos, or different you are posting your you are listening to the classes or something else. In that case, it is the cable is not capable of taking more than 20 Mbps. That there may be a traffic would be happened in that particular cable, is nothing but your congestion. Okay, how this congestion is evaluated and how it is minimized in your network with the help of network service. So we are going to have some of the best network service models, some of the network service models. In this, we are going to have all the things, some of the network models, that in that network models, we have some models. In that models, there may be a chance of having less amount of these service models may rectify your doubts. That means first one is will it reach properly or not, multiple in order of that particular sequence of that particular frames or the datagrams, or the time between the two sequential packets and conjunction. These are the four doubts you have. There may be there are so many network service models define the characteristics of some characteristics. Some network models will have some what you say capabilities are and every some network models will possibly they will define all the four doubts of your four problems of your transport layer or some other layers according to your knowledge. Okay, that we are going to discuss. Sorry. Okay, services provided by the network layer, and we need some more things. This particular service what you say network service models, what network service model will expect, these models, from these models what we are expecting. Okay, first one is guaranteed delivery. First one is guaranteed delivery. Okay, with bounded delay. Second one, guaranteed delivery with bounded delay. This service guarantee, first one is guaranteed delivery, that packets will eventually arrive its destination. Compulsory, it is going to reach at the destination. Guaranteed delivery. Guaranteed delivery with bounded delay. Okay, this services not only guarantees the delivery of that particular, but delivery within the specified host to host delay bound. Okay, within that particular thing. That means if you are both the devices are in 100 meters or 200 meters distance, how much time bounded delay bound in the how much time it may take to, if we have delay also, in that particular time will it reach that particular device or not. That is nothing but guaranteed delivery with bounded delay. This is the next service model expectations. Okay, next we are going to have in order packet delivery, that we have discussed in order that particular. This service guaranteed that packets arrive at the destination in the order that they were sent. That means how, in what way, in what order that particular packets are sent, that should be reached at the same order at the destination point. Guaranteed minimal bandwidth. That means this service emulate transmission link a specific bit rate. That means whenever I'm using any band any link. Okay, in that particular link I need to have some fixed particular bitrate. In that particular bitrate only I have to forward the messages. That means packets. Otherwise what will happen, if the bandwidth link is capable of 1 mbps, if you are passing the more number of frames, more number of frames, more bits in that particular second, it is going to have congestion. Okay, next, guaranteed maximum jitter. That means you are going to have the time between both the packets is equal or uh, not more difference. Okay, we are not going to have more difference. That means within the milliseconds only the two successive packets must be reached at the same at the receiver end, as like your YouTube audio video kinds, not lots of seconds. That means less amount of time it is going to take, not more than that particular thing, in the microseconds or nanosecond, not more than that thing. Okay, and security services will that particular, with the help of secret session key, the source and only the source and destination host, the network layer, the source could encrypt the particular payload, and the receiver can decrypt the payload datagrams between the source and destination. That means with the help of we need to have a session key, secret session key, that is private key, which can be encrypted and at the sender end, and decrypted at the receiver end of that particular datagram. Every datagram of that particular thing must be encrypted and decrypted with the security services at the both the ends with the help of network layer model. If you have any doubts in middle, please speak. You can chat in the chat box, ma. Don't be sit idle. If you are sitting idle means you are not going to understand the properly. So if you are getting any issues, any you are not understanding, in that case you can chat me. Okay, you can post a message in chat box. Okay, next. Okay, these are the 4 5 things we are going to understand in that particular thing. Now we are going to have some of the models. Okay, there are two models are there. First, internet ip architecture. Next one is asynchronous transfer mode. Okay, asynchronous transfer mode and internet architecture. In this case, either service model is best effect, or CBR constant bitrate, or ABR available bitrate. These are the three service models. These are the, we have first architecture, two different types of architecture: internet, ITM. We will have some more other, but here we are discussing only two, that is internet and ATM. Okay, asynchronous transfer mode is the one network architecture. Internet protocol, IP architecture, internet protocol. Okay, that is one architecture. There are two architecture. These two architectures are taking care of best effort service, and constant bitrate. Next, available bitrate. These are the three service models we are discussing here. Okay, if we are taking internet, compulsory we are going to have best effort service model. Okay, with the best effort model, what we are going to get? Bandwidth guarantee? No, we do not have. In this service model, we do not following bandwidth guarantee. Okay, whenever you need, you take that particular thing and you use that particular thing. We are not going to have bandwidth guarantee. That means every time I can forward 1 mbps data only, like that it is not going to use in internet. Okay, no loss guarantee. There is no, like that we are not following any no loss guarantee. Every time if you lost something, you have to retransmit the data. That's it, simply. We are not going to no have the no loss guarantee in internet protocol. Best effort service, internet architecture best effort service. Okay, next, ordering. In this, any order is possible. We are not following any ordering things. That particular at the receiver end, and sender and the receiver has to make their own things. That means ordering, the sequencing of that particular packets will be taken care by sender and receiver, not the your best effort service network layer. Okay, any order is possible. It is not the depending on the a particular same order only it is going to change. Okay, now timing, it is also not going to maintain that particular timing. Okay, conjunction indication, that means if the cable or the link of that particular link is busy, in that case, are you going to send any alarm to the sender and receiver or the network layer? In this internet best effort, that particular thing, we are not going to maintain any conjunction indication. Okay, this is the first thing. Next, asynchronous transfer mode, CBR. Okay, constant bitrate, ATM constant bitrate. In that, guaranteed constant rate bandwidth guarantee is there. That means whenever you are maintaining that particular thing, that cable is 1 mbps or 2 mbps, in that rate only we are going to forward and we are going to receive the information. Okay, no loss guarantee, as we are in constant bitrate. Constantly we are sending the same bitrate in the sender and receiver side. So there is a no loss guarantee is there, as we have that particular facility in the ATM CBR mode. Okay. Ordering, we are following the same in order protocol. So okay, in order, that means you are going to have the packets from the receiver end to sender end to receiver end will be the in order. That means sequencer would be following, and your network layer is responsible, and your this model is responsible to have the order. Okay. Next, timing is going to mention timing is also going to mention. Congestion will not occur. That means whenever you are sending constant information, that means 1 mbps per every second we are going to send 1 mbps according to you, that you are sending. In that case, there may be there must not be having any congestion. Okay. That is we are going to give the guarantee. Why? We are sending on the first network itself, the device itself, network layer itself is going to constantly, it is sending the constant bit rate only we are going to send. So we are do not have anything particular thing. Okay. Now, ATM with available bit rate. Here you see ATM with available bit rate, guaranteed minimum bandwidth. Okay. Guaranteed the minimum bandwidth. That means you have to use most if you are having 10 mbps of link. In that case, at least it is going to guarantee the less thing. Minimum guarantee is to be there, but particular thing first, bandwidth guarantee, we are not going to that particular we are going to exhaust that particular thing. Just we are going to guarantee the minimum thing. Okay. No loss guarantee, we are not going to give you any no loss guarantee. Why? We are there may be a chance of, if you are constant bit rate, in that case we are going to send only, there may be a chance of having congestion. If the congestion is happening, that means you're your link is busy with something else. In that case, you will have, there may be a chance of having lossy packets. You may have lost some packets. In that case, we are not going to give the guarantee that particular. Next, ordering. In order, in this also ATM synchronous transfer mode also we are going to take in order packeting. Okay. In order packeting only we are forwarding. We are not depending on out order things. Okay. Next, timing. We are not having the, we are not maintaining the particular timings of that particular sender and receiver, and the mm, mm, time between the two packets. We are not going to maintain that particular. There may be a chance of any time it can be reached, or that particular maybe delay between the two sequential packets. Okay. Next, conjunction indication provide. That means if the link is busy. Okay. If the link is busy, in that case you are going to, your link is going to send, or your this service model is going to send some indication to the receiver, sender or receiver in that particular thing. Okay. If you are using this particular models, burst effort model, constant bitrate model, or um, available bitrate, how your network service, these models are going to work in that particular criteria, that we have discussed in that particular. These are the some of the service models, network service models in that particular guaranteed bandwidth or noisy. If you are choosing this one particular thing, you are going to utilize. Okay. In this if you are choosing ATM CBR, constant bit rate, you are going to get all the bandwidth guarantee, no loss guarantee, ordering in order, timing mentioned in that particular thing. Congestion will not be occur, it is not going to occur also. Okay. That service model, according to your convenient, you have to choose the which service model is going to useful for your network or your applications. Okay. This is all about network service model. Next, Do you have any doubts ma in this network service models? Network service models will have these four problems. To solve that particular thing, we have every problem. You cannot say that is every problem you can solve. That means every individual application will have its own thing. That means some information like not secure information, that is not related to money or some information you have to pass broadcast that particular information. In that case you need not to have security, as like your uh, TV channels. You are broadcasting any TV, that means news items or particular uh, serials or movies. In that case, you need not to guarantee that security. Okay, some of that particular thing needs guaranteed whenever you are sending any information. YouTube you are using, in that particular thing you need to have better effective jitter kind of things. Okay, that there must not be more delay between one packet to another packet. It would be very difficult for us for that particular thing. If you some applications will not use something, so according to your application which is the best one, that you decide. Okay, here we have some service models. According to that, we have discussed the some of the best effort service model, and constant bit rate, available bit rate. Whatever the available bits, what is the rate is there, according to that it will move on that particular thing. These are the service models of your network layer. Okay, now coming to the services, connection oriented, connection less services. Why we are discussing this is we are going to discuss about datagram and virtual circuit networks. First one is datagram, virtual circuit network. After that we are going to discuss about datagram. First, virtual circuit network is nothing but a connection oriented service. Connection oriented service means your mobile phone or landline is depending on virtual circuit network model. Okay, your mobile phone, when you are you understanding ma? I hope you understand this thing. Virtual circuit is nothing but connection oriented, and as like your mobile phone or your landline thing is nothing but your virtual circuit network. Your landlines and your mobile phone follows connection oriented virtual circuit networks. Okay, datagram networks, your WhatsApp messages or your email things, these kind data transfer is considered as datagram networks. Okay, this is the connectionless network. What is the difference between connectionless and connection oriented service? We will discuss first. When virtual circuit is the connection oriented service. In whenever I'm saying virtual circuit, mobile network or your landline. Okay, first I will pick my phone and I will dial one number. Okay, xyz number I will dial. Okay, whenever I'm dialing, this is the first action. Okay, first action. Second action, this information, dialing information goes to the receiver end. Okay, he will get his mobile also rings. Okay, this is the second information. Third thing, what it will do, either he will accept the call or reject the call. Okay, first if he accepts the call, okay, that is the third one. After accepting that particular thing, you are going to get the connection is established between sender and receiver. Okay, after connection establishing, you are going to data transfer, you are going to talk to that particular person. Okay, the information is received to that particular thing. Whenever he is responding, that means he is speaking to back to you. That means your acknowledgement thing will be come from the receiver to you. Okay, like that, that particular information comes to from receiver to you. Okay, at the end you are going to cut the call and you are going to close that particular conversation. That means your Everything is connection oriented. If the connection is not there, you are not going to connect to that particular person. You are not. If the both the persons are available, then only this network connection would be possible. Otherwise it is not going to possible. In datagram network, I am sending a WhatsApp message to my friend XYZ. If I am sending a packet, a high message, if the receiver is not there, receiver mobile number, if he is not connected to the internet, in that case your data is not going to reach that particular thing. But after he, whenever he connects to that particular thing, he is going to receive that message using this connection less services. Okay, datagram services. In this datagram services, you are sending some messages, but it is going to store somewhere else, or it is going to stay store in that particular buffer or the queue. In that particular queue it is going to store. Whenever he connects to that particular network, he is going to from that queue it is going to reach that particular user. It is not going to lose, or there may be a chance of having losing of that particular messages also in datagram. But in the network, virtual circuit networks, we cannot lose anything. If you lose, just your total network will, your phenomena is going to cancel, and you have to restart first onwards. You are not going to, in middle is there any loss is there, you cannot recover that. You have to restart all the virtual, and again you have to reconnect the virtual network, circuit network, and you have to do. Okay, analogous to TCP and UCP, transmission control protocol. TCP, transmission control protocol, is connection oriented protocol. UDP, user datagram protocol, UDP, user datagram protocol, is connection less transport layer services. Okay, TCP and UDP both are the connection, these are the transport layer services which are using in transport layer. Okay, these are connection, or TCP is connection oriented, UDP is connection less services we are using. With the help of this particular thing, we are going to use service at the both the things, connection oriented or connection less. In these cases we are going to use host to host delivery is going to be happen. No choice. We do not have, if you are using TCP virtual circuit, you have to use, if you are calling using calling, in that case you have to use virtual circuit. If you are messaging, texting, in that case you have to use UDP. There is no, that means I will skip TCP IP, both the things. In that case you are not going to establish the connection between the sender and receiver. There is no choice, you have to any one of that particular datagram or virtual circuit network you have to establish, otherwise you are not going to get connected to the receiver. Okay, implementation according to your network core. That means either if you are using calling, in that case your virtual circuit network is going to be taken care. That implementation will be in the network core itself, network layer only itself. It is going to either TCP, it is going to use RUDP, or virtual circuit or datagram networks, it is going to use in your network layer. Okay, give me a minute ma. After that we are going to start with the virtual circuits. After that I'm going to start datagram, tell you about datagram. Okay, as we discussed virtual circuits, okay, we are going to see this particular thing, virtual circuit. What is virtual circuit, how it is going to source to destination path behaves much like telephone circuits. Source to destination path behaves much like your telephone circuit. That means how we are discussing, how we have discussed just now, as like your source to destination path. That means you are transferring the data from source to destination, as it will behave like your telephone circuits. Okay, telephone circuits. That means every time you are calling, at the receiver end you will get a notification. He will accept the call or reject the call. Whenever he accepts the call, he is going to establish the connection. After establish the connection, you are going to transfer the data. Okay, after getting the acknowledgement, your all things are done. After that, you are going to close the information and you are going to cut that particular thing. This is the behavior of your telephone networks. Your virtual circuits will behave like this only. Performance wise, it is very good at performance wise, I can say. Why? Whenever your network is connection and it is totally your connection is, your link is depending on the connection establish two-way handshaking. Okay, whenever you are saying hi, if you get the acknowledgement, then only you are going to transfer the data. Otherwise you are not going to push the data. Otherwise what will if you are not pushing the data means there may be there is no chance of having congestion or traffic in particular network. Okay, the performance, it is the best thing. Okay, network actions along with the source to destination. Network will also works along with source to destination path. That means whenever I am transmitting the data from I want to establish a connection between one person source to destination, I will have the path, source to destination path. It is going to establish the path. Whenever I get the acknowledgement, then only I will, okay, transfer the data. Here you see some of the points. Call setup, tear down for the each call before the data can flow. Okay, first you have to either dismantling, or that particular call setup must be happen, or that call must be close between sender and receiver before the data can flow. Okay, each packet carries VC, virtual circuit identifier. Virtual circuit, each packet. Okay, virtual circuit identifier, not destination host address. That means whenever I'm establishing a connection, if I have a host address, not the virtual circuit identifier, what will happen? I can transfer the same voice through different hosts. Okay, virtual circuit identifier. Whenever I'm saying virtual circuit identifier, in that particular call only, that means that link only, I have to transfer the voice from source to destination, not the any other. That means call disturbance would not be there. Call jumping should not be there because of this voice identifier. I'm one thing, ma. Mm, I am explaining these things with your telephone network means not the meaning of that we are using virtual circuit and other things. How virtual circuit model will be developed, is developed, that we have to understand, analyze that particular thing with the help of some example. Example is nothing but your telephone network. When I am taking the telephone network, why, and that's the reason I am explaining you. Not that particular thing it has only virtual setting, it is not like that. Virtual circuit will have only telephone networks only, it is not like that. You have different things would be there in that particular virtual. When you are connecting the virtual, this is the set of protocol. Network layer is all the networks layers are the developed in the simple protocols. Either you use, you are not using, we are not caring, but if you use, it will work for all over the world. If you are not using, that means someone can use that particular circuit, someone cannot use that particular thing. Okay, give me a minute, ma, I will come back. Okay, now uh, each packet carries virtual circuit identifier. That means that particular virtual circuit, that means you have a connection between ABC to XYZ. These are the two peoples who are these two peoples are using one telephone network. That means the data transfer through this link only, not other than that particular link. That data must be identified. Each packet must be have the same path and that particular link only, virtual circuit only, not other than. In that case, it is going to have call jumping and the data transmission would be effective. Okay, every router on the source destination path maintain state of each passing connection. That means every router, that means whenever I am transferring the data from uh, I am calling from Hyderabad to Vijayawada, every router is nothing but your network signals, geo towers. Every router and source to destination path maintain particular states. Okay, from here to I have to connect to the my Hyderabad or Narayanguda's tower. From there to some other Hyderabad Central Tower. From Central Tower to, it is going to connect to the Vijayawada Central Tower to that particular bench circles, that particular center tower. From there to directly the receiver's host. And at the same time, it has to maintain the state of each passing connection. That means how these the state means nothing but is connection established or connection closed. Everything it has to uh, maintain. Otherwise, what will happen if the connection is established? I have disconnected my call, even though I have disconnected my call, your virtual circuit has not stopped. In that case, what will happen? That burden will be very high to your network. Okay, that's the reason we will have that. Link router resources bandwidth buffers may be allocated to the virtual. Okay, your bandwidth, some bandwidth must be allocated to that each and every virtual circuit. Okay, dedicated resources means predictable service. That means whenever you are in some connect call is connecting through Hyderabad to Vijayawada, in that case it will take some bandwidth between this particular thing. And but for space, how much buffer? There may be a lag between the sender and receiver. There may be must be, whenever I am transferring that particular thing, it should be have some buffer space. That will be resource will be allocated previously while you are creating the VC, virtual circuit networks. Okay, implementation. A virtual circuit consists of path from source to destination. Before itself, whenever I am transferring the data, if I am connecting to the particular thing, the path of that particular source to destination is consisting of that particular virtual circuit. We see numbers, virtual circuit numbers. Every call must be having every call or every virtual circuit must be having some particular number, one number for each link along with path. Okay, is nothing but your VC numbers. Entries for the in forwarding table in routers along with path. That means whenever I'm transferring that particular call, the call history must be logged in the your call history or your virtual circuit entry must be logged in the forwarding table. I am just simply I'm making you to rememberize all the things. I'm making this thing. Whenever I'm saying call information, that history must be your receiver end and receive at the sender end and receiver end, as well as your routers. Routers is nothing but your telephone exchanges between that particular thing. Every entry must be forwarding, must be uh, saved in the forwarding table. Okay, next time it is going to take that particular thing, same forwarding table, same link should be taken case. Packets belong to the virtual circuit carries virtual circuit number rather than destination address. We have discussed it just before. If I am using destination address, that is destination address is nothing but your mobile phone number. But if I have connected through my work telephone exchange, my network, my connection is established. After establishing, if I have only the receiver, in that case I may use different paths rather than using this virtual circuit. So that's the reason you have to use virtual circuit number only, not the destination address. Virtual circuit number can be changed on each link. Okay, every time if I am using different links, each link will have different virtual circuits. That is not the case. Okay, whenever you are connecting through Vodafone network, that is a particular thing. If you are connecting to different networks, in that case your virtual number VC number may different from one person to another. Other person will have different. If you are using Geo, other person is Airtel. In that case, that there is a cross platform and all the numbering would be different from one link to another link. Okay, new virtual circuit number comes from the forwarding table. Okay, if you are changing that particular thing, it is coming from forwarding table. Every router will have that particular thing. Okay, yes, you see virtual circuit forwarding table, it has four entries: incoming interface, incoming virtual circuit, outgoing interface, outgoing virtual circuit. Okay, in the red color thing here you see the diagram. Here you have four switches and host and destination, and four switches. Okay, each and every switch have the forwarding table. In this forwarding table you will have incoming interfaces, okay, and incoming virtual circuits. Okay, this particular interface is nothing but your link. Total black color link is nothing but your interface. Okay, we consider as one link. But virtual circuit means the bandwidth is allocated to that particular call or that particular message transmission. Okay, that is incoming virtual circuit number 1 2. Okay, and I have connected through different interfaces. Number one, my first uh, router is connected, a switch or router is connected to the 1 2 3 different cables or network links. But whenever I am transferring that particular outgoing interface, when I connect it to 12, outgoing interface is 3. My connection is connected through my data is transferring to the next link, that is 3. And outgoing virtual circuit number, here it has changed 12 to 22. Okay, at the receiver end 32. This network will take care. You do not worry about that particular thing. Sir, I have called with 12 number virtual circuit, but the receiver end it has connected through 32 number virtual circuit. But the virtual circuit is same here to here. Your forwarding table with the four entries: incoming interface and incoming virtual circuit, outgoing interface and outgoing virtual space, it is going to maintain all the four entries in the virtual circuit router maintain connection state information also, where it is particular thing, and each and every way it is going to maintain that particular thing. Okay, next, virtual circuit signaling protocols. Here virtual circuit, how it is, whenever I have already discussed that particular thing about this thing, virtual circuit signaling protocol. First, Used setup maintain tear down virtual circuit used in the ATM frame relay expand to find, not used in today's internet. Right now we are not using this particular thing, okay, virtual thing. But here how this virtual circuit will work, you see. First number initial a call, that means you are dialing a number. At the receiver end incoming a call, you are get the receiver will get the call. Third thing, accepts that particular call. Whenever once the accepts the call is connected to the source to destination. Okay. Fifth one, data is after connecting the call, he is going to transmit the data, he is going to talk to the particular person, he will start the declaration. Whenever he receives the data, that is the thing, and he replies the particular thing, it is the full display that he replies that particular. After all this system, you are going to close the virtual circuit. This is the signaling protocols in this particular thing. Okay, these are the four things. 1 2 3 4 call connection. Till call connection, you are going to data transformation and receiving data acknowledgement. Your network layer is not going to take care. Okay, your network is not going to take care. But here red color, data transformation, flow control, all the things, the other things will be take care. But virtual circuit is going to take initial call, incoming call, accept the call, call connected, that establish VC, establish the particular network layer. Okay, your VC is going to establish. Next, till this is the connection oriented services. This is the virtual circuit is the connection oriented services. But we are going to discuss about the datagram networks. In this, we are not having any connection, we are not going to establish any connections, but we are receiving the information from sender to receiver without any issues. Okay, here we are sending the datagrams, second side we are receiving the datagrams. No call setup at the network layer. Routers, no state about end-to-end connections, no network layer concept of connection. We are not going to have any connection kind of thing in your datagram networks. Packets forwarded using destination host address. In this connectionless oriented UDP, user datagram protocol, in this we are just relying on that particular destination address. Why? When I have hundreds of packets, each packet has a sequential addresses. Okay, in this, whenever I'm sending the hi message through WhatsApp or message, you are using mobile messaging system, text messaging system. In that particular thing, what will happen? Your data, hi, how are you? You are typed and you are sent, but the receiver not getting. But in that time, he is not connected to the internet. In that case, what will happen? All the 10 or 15 packets that are sequential, the packets are those sequentials. Okay, every packet has the destination address. Okay, so every packet, we are not here near, we are not having the virtual circuit or the network connection kind of thing. Just adding, we are transferring the data to the receiver side. At the receiver end, with the help of sequential order, we are going to add them particular thing into one particular thing. Okay, at the receiver end, we are going to uh, again we are clubbing all the packets into one, and we will get the information at the application layer. With the help of network layer, only just that send the datagram, receive that. We are using destination address, not the circuit address. Here you see how this particular thing will happen. Okay, with the help of IP addresses. Okay, we have here my network cable router is there. In this, first one is link. In link means I'm getting the data from that particular link. Okay, other than in link, I have three outlinks, 1 2 3. 1 2 3 outlinks are there. With the help of my local forwarding table, I am going to forward that particular data packet to the destination. Okay, there are 4 billion IP addresses. So rather than list individual destination addresses, list the range of addresses. Okay, first 1, 2, 3. Okay, within the particular 1, 2, 3, 1, 2, 3, to which router I have to forward either 1 or 2 or 3. With the help of this forwarding table, I am going to take. I have classes ranges, 4 ranges in my addressing tables. 4 ranges: range 1, range 2, range 3, and range 4. Okay, range 1, range 2, range 3, and range 4. If my IP address is comes under range 1, I'm going to forward to third. Okay, according to that is not third is not fixed thing. According to the output link of that particular router, I am going to forward. If it is coming under range 2, in that case it is going to forward to the next two. Range 3, it is going to forward to the same thing, 2 only. If it is coming under range 4, in that case it is going to forward to the first link which is connected to the rail. How? We are going to see in the next slide here. Ranges ranges here you see link 0, link 1, link 2, link 3. That means your IP address is 32-bit IP address. Okay, here you see 8 into 1 2 3 1 2 3 8 into 4, 8 into 4, 32-bit IP addresses only. Not, you may not have more than this particular IP addresses. Okay, all over the world. Okay, first, if it is the your IP address from here to till here last uh, third octet. These are the first octet, second octet, third octet, fourth octet. Third octet, one double zero double zero all zeros to 1 0 triple one triple one triple one double zero till here. From here to here, you are going to pass through link interface 0. Okay, here I have added one extra. Okay, 1 0 0 0 0 to here, 1 1 1 0 0 0 0 1 1 1 1. Okay, like this you have the ranges from address ranges. Okay, these are the IP addresses. If it is beyond that particular thing, in that case you are going to send through link 3. But what happen if the ranges does not divide up so nicely? Here this is not nothing but 10.11.36.19 or 35 192.168.1.2. Like this is nothing but a number, single number, 11000100. Your IP addresses will have 10.11.56.35. Like this you will 10 10.11.36.55. Okay, if it comes under this, your forwarding link is 0. If it comes under this, it is going to comes under this. If it is not maintained properly, you are not going to have lots of problems. Okay, that's the reason we have considering here longest prefix match. Here first destination 1 0 0 0 0 0 0 0 0 till here I'm considering. After that, star means wildcard characters. Whatever you have, 0 or 1 2, not, I don't care. Till here I'm going to consider. If it is this, I'm going to forward to link interface. Okay, next link I'm going to check 10, first 10 till 10 I'm going to check it is. If it is 10, I'm going to forward it to 0. If it is 11 0 0 11 0 0 in that case I'm going to forward to the next link. If the link is double one other than zeros, that means 0 1 2 3 1 1 1 or 101 or 1, whatever it may be, I'm going to forward to the next two. Otherwise I'm going to forward to the link 3, link interface 3 I'm going to forward. Okay, you have a question here. First one, the data given is 1100. Which interface I have to forward? Which interface I have to forward? First one, answer. Please respond in the chat box. We are going to stop within 5 minutes. I have a data ranges here. Which interface? This is the which interface. This is the what interface. Okay. Please respond me in chat box. Link 1 interface 0. Okay. Link interface 0 and link interface 1. Okay. Good. Why? Last triple star 10111. Okay. Give me a minute, ma. I'm coming. Okay, ma. With this, you are going to understand that particular IP addresses, and it is going to forward the link interfaces in datagram services. That means when you are sending your mobile phone or particular thing in that particular mobile phone or your IP addresses, with the help of IP addresses, you are going to define that particular thing. It is going to forward the data with the help of this ABCD 0, 1, 2, 3 links. It is going to consider and it is going to forward that particular interfaces. Okay. Now, are we using datagram or virtual circuit? You are going to use datagram circuit or virtual circuit network. Why? What are the advantages we are going to discuss here? Okay, in the both the cases you have advantages, disadvantages along with this particular things, both the things. Okay, internet datagram, it is using datagram. ATM, asynchronous transfer mode, it is going to use virtual circuit network. What are the what are the things, good things, bad things, we are going to discuss. Data exchange among the computers. ATMs evolved from telephony human conversation. If you want to develop application for transferring the telephony human conversation, in that case, you have to choose ATM model, ATM service model. Okay. If you want to transfer the data exchange among the computers, either your email address, or emails or particular data, what you say, messages, WhatsApp messages, Facebook links, all the things will be exchanged among the computer. In this case, you can choose datagram, okay, or internet. Okay. Now, here elastic service, no strict timings required, but strict timings reliability requirements. Why? Whenever a particular person is calling, the other person has to attend the call. Otherwise, ATM will not work. But here you can post some information, message, WhatsApp message or something else. You can post the particular thing. Whenever he receives that particular, whenever he connect to the network, whenever he particular thing, then only it is going to receive that particular. Okay, many link types would be there, requirements would be there here, different characteristics would be there. Uniform service, difficult, you need not to. That means whenever uniform services means you will have using some laptop, some other person using desktop computer, whatever it may be, there's different. There is no uniformity, that particular thing. Okay. Smart end system computers must be used here, can adopt, perform, control, error recovers. The error recovers, you will be connected, adapting all the things. Simple inside network, complexity at edge. Network, inside the network it is simple, but all the edges it has more complex in the internet. Okay, but complexity inside network. Why? Every call has to be taken care by your network layer, and virtual circuit must be generated between the two links, and your bandwidth would be fixed in size. Okay, all this what particular thing need for guaranteed service, dumb end systems telephones. Okay, this is the all about your datagram and virtual circuits. If you have any doubts, please let me know, ma. Please respond in the chat box. Just simply virtual circuits and datagrams. Datagrams are nothing but connection less. Virtual circuits connection oriented. Please respond me on the chat box if you have any doubts. I'm going to activate the quiz also meanwhile.